In this video, we're going to look at some additional trigonometric equations, in particular, ones that involve multiple angles and the tangent function. In this first example, we're asked to solve 2 times the sine of 3 theta minus 1 equals 0 for angles theta between 0 and 2 pi. We're going to start by solving this equation as if we were solving for the angle 3 theta. And so in order to do that, we would first add 1 to both sides to obtain 2 sine of 3 theta equals 1, and then divide by 2 to get sine of 3 theta equals 1/2. And other than the 3, this would be one of a very simple trig equation that we could solve. We have sine of some angle equaling 1/2. And we know that if sine of some angle is equal to 1/2, that angle, in this case, which would be 3 theta, needs to either be pi over 6 or 5 pi over 6. Pi over 6 is the angle in quadrant 1, and 5 pi over 6 is the angle in quadrant 2, whose sine is 1/2. Now, we might try to divide this equation by 3 to obtain equations for, or values for angle theta, and we are ultimately going to do that. But before we do, in order to make sure we get all of the angles theta that work, we need to actually write down the formulas for all equations, for all angles, not just those between 0 and 2 pi. And so in order to do that, what we would do is just take each of these, pi over 6 and 5 pi over 6 respectively, and add all multiples of our period to each. So 3 theta equals pi over 6 plus 2 pi k, and 3 theta would be 5 pi over 6 plus 2 pi k. We can then take these equations and divide both of them by 3 on both sides, and so we get theta is going to equal pi over 6 divided by 3, which is pi over 18, plus 2 pi k all over 3. The second equation becomes theta equals 5 pi over 18 plus 2 pi k over 3. And so this then, this pair gives us all the solutions to this particular equation in terms of angle theta, not 3 theta. Now, in order to determine all of them for theta between 0 and 2 pi, we simply have to start listing out our solutions here. So for example, when k is equal to 0, remember k here is any integer. When k is equal to 0, we simply get theta equals pi over 18 plus 0, and theta equals 5 pi over 18 plus 0, which is 5 pi over 18. And so k equals 0 gives us these two angles, and they both fall in the appropriate range. Both are positive angles and are obviously less than 2 pi. We're then going to let k equal 1. And so what we're going to do is add 2 pi over 3. So each of these will add 2 pi times 1 over 3 to each of these two numbers. So our first would be pi over 18 plus 2 pi over 3. And this would be 13 pi over 18. And our second angle will be 5 pi over 18 plus 2 pi over 3. And this will give us 17 pi over 18. And so we get these two values, these two angles here as well. So here are 4 angles so far between 0 and 2 pi that we will get that work for this particular equation. Right? Now, we can continue with this kind of in the same idea. We're going to then do k equal to 2. And so in this case, we're going to add 4 pi over 3 to each of these solutions. And I'll leave the arithmetic to you, but starting with pi over 18 and adding 4 pi over 3 will give us 25 pi over 18. And 5 pi over 18, adding 4 pi over 3, will give us 29 pi over 18. And so these will also be two angles that meet our desired range. Both are positive and less than 2 pi. Finally, we're going to check what happens when k is 3. So here we're going to end up adding 6 pi over 3, which is 2 pi, to these values. And so if we do that to our first angle, pi over 18, and we add 2 pi to that, then notice that we end up getting 37 pi over 18. And we can stop at this point because we realize that this angle is too big. This angle is now bigger than 2 pi. We actually did not even need to compute it because just saying that we have pi over 18 plus 2 pi is going to indicate that it is bigger than 2 pi. And so it is outside of our range. So these 6 indicated angles here are all of our solutions to our equation between 0 and 2 pi. We have pi over 18, 5 pi over 18, 13 pi over 18, 17 pi over 18, 25 pi over 18, and 29 pi over 18. If you'd like to try a similar problem, try to solve the equation cosine 2x equals 1/2, where x is between 0 and 2 pi. The solutions will appear in just a few seconds. This equation has 4 solutions between 0 and 2 pi, namely pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now we'll take a look at an example of a trig equation involving the tangent function. Most of the same rules apply. The only difference is that we need to remember that the tangent has a period of pi, not 2 pi. And so the first thing we want to do with this example, where we want to solve tangent squared of theta equals 3, is isolate tangent of theta. In order to do that, we need to take the square root of both sides, but remembering to include the plus or minus square root here because we want to include both possibilities. And so what we really want to do is solve 2 equations. The tangent of theta equals the positive square root of 3, and the tangent of theta equaling the negative square root of 3. And so we want to solve both of these. In particular, we want to solve both of these on the range 0 to pi, because this is one period of the tangent function. And so between 0 and pi, there is only one angle whose tangent is square root 3, and that angle is pi over 3. If you don't know that one off the top of your head, that is okay. You can just simply use that we only really have 3 options, pi over 3, pi over 6, and pi over 4, and you could quickly just compute the tangent of each by thinking of tangent as sine over cosine. And if you did that, you would see that tangent of pi over 3 is indeed square root 3. For the second equation, we want a tangent equaling a negative square root 3. And so this would indicate, the negative sign indicates that we are in quadrant 2, and otherwise being the same numerical value tells us that we have a reference angle of pi over 3. And so here we get theta being 2 pi over 3. So these are the 2 angles that live between 0 and pi with a tangent of either plus or minus square root 3. In order to write all of our solutions, then, we simply write these with all multiples of the period added to each. The only thing we have to watch out for here is that our period here is going to be pi. So we're going to add pi k to each of these. And k, as always, is any integer. And importantly, again, just to emphasize this one last final time, the period of the tangent function is k. And is pi, not 2 pi, like it was for sine and cosine. And so this is one little caveat to watch out for when dealing with the tangent function in an equation.